higher precedence than less precedence than theta 1. Now, if operator theta 1 and theta 2 have equal precedence and they are left associative, in that case you can write that starting from theta 1 to theta 2 that we have seen in case of ID and ID like these things. That is, in case of left associative, here we will see the precedence relation theta 1 greater than theta 2 and theta 2 greater than theta 1. If theta 2 is starting first, followed by the theta 1. But if they are right precedence, right associative, then in that case it will be theta 1 lesser precedence than theta 2 and theta 2 will be lesser precedence than theta 1. And for any operators theta, theta has less precedence than ID, that is ID has greater precedence than theta, theta has less precedence than opening parenthesis, theta has greater precedence than closing parenthesis. That is, you just see as per the rules. Now theta has greater precedence than dollar, that is dollar has less precedence than theta, like these things. You just see these are the several precedence relations. And this is the defined precedence relation as per the precedence relation rules. These are the defined precedence relations. As you just see plus and plus. Plus is left associative. In that case, this plus has greater precedence than next plus. Like these things. Plus has greater precedence than minus. Plus has less precedence star. Plus has less precedence than division. Plus has less precedence than exponential. Like these things. See this table, and any confusion you just ask me regarding these things. Precedence relation. Is it okay?
Yes, sir.
Okay. Now is the handling unary minus. Operator precedent parsing cannot handle the unary minus when we also have the binary minus in our grammar. Unary minus, binary minus, minus b. Here unary minus. A minus b is the binary minus. Now, best approach to solve this problem, let the lexical analyzer handle this problem. That is, the lexical analyzer will return two defined tokens for the unary minus and the binary minus. And the lexical analyzer will need a look at to distinguish the binary minus from the unary minus. That is, you just see for any operator, unary minus has higher precedence than that operator. Now, this is generally we know unary minus has always higher precedence than any other operator. And if some operator unary minus has less precedence, then you can write in this way, that is unary minus less precedence than theta. Okay. Now, next one is the precedence functions. Actually, based on a graph, we will try to find out the precedence function also. Compilers use precedence parsers do not need to store the table of the precedence relation. That is, in order to find the precedence relation, in case of the design of the compiler, you don't need to store this precedence table. But a compiler, based on the graph, it will find out the precedence relation. That is, table can be encoded by two precedent functions, f and g, that map the terminal symbols into integers. That is, for any symbols a and b, fa less than gb, that is when a has lesser precedence than b, fa equals to gb when a equals to a has equal precedence to b, and fa greater than gb when a has greater precedence than b. This is the way constructing the precedence function has been done. Now we just see what are the rules for doing that is constructing the precedence functions. It's very important. Just try to understand these things. Create symbols FA and GB for each A and B that is a terminal or dollar. Create symbols FA and GB for each A that is a terminal or dollar. Partition the created symbols into as many groups as possible in such a way if A equals to B, that is A has equal precedence to B, then A, FA and GB are in the same group. Now create a directed graph whose nodes are the groups found in 2. That means for any A to B and A has lesser precedence than B, place an edge from the group of GB to of FA. That is B has higher precedence, place a node from GB to group of FA. Or if A has greater precedence, then place a group from FA to that of GB. Now, if the graph constructed in 3, that is partition graph you are getting, has a cycle, then no precedence functions exist. We will not be able to find the precedence functions. Otherwise, if there is no cycles, then FA has the length of the longest path beginning at the group of FA. Let GA be the length of the longest path beginning at the group of GA or GB, better to say. Now we just see. This is a precedence table is given. Based on these things, you are going to find out the precedence relation. How to do these things? You just see. A plus. What we have see? F ID group in this way, FID, GID, F star, G star, G plus, F dollar, G dollar. And now you just see GID. GID has greater precedence than F plus. That is why I put a H from GID to F plus. Like FID has greater precedence than G plus. We put a precedence that H from this to this, like this. F star. F star has higher precedence than G star. We put a symbol from there. What is the meaning of these things? How the table is formed, basically. You just see. F dollar and G dollar, listen carefully. F dollar and G dollar has no out edges. F dollar and G dollar has no out edges. That is why F dollar and G dollar has the zero precedence. Zero precedence. Here actually what we have done, we just know as per the precedence relation, we just put a symbol from this to that. Now, the longest path from G plus, longest path from the G path, that means longest out edge from G plus, this is only 1. That is why we have put in the table 1. Like that, if we consider GID, longest path from GID, you just see, longest path from GID, 1, 2, longest out edge from the GID, 1, 2, 3, 4, 5. That is why we have put 5 here. FID, longest one, 1, 2, 3, 4. That is why I put 4 there. In this way, that means what is that? Longest path from the any GA or GB or FA or AB, and that will be its precedence function. That means that will be its precedence functions. Here you just say precedence functions, that is we have seen FID is 4, GID is 5. That is why GID has higher precedence than FID, F plus has higher precedence than G plus. In this way, we can proceed. And this is the way, that is, this is the graph which denotes the precedence relation. This is the graph which denotes the precedence relation. And in this way, basically, compiler finds the precedence relation. Is the precedence graph is okay for you? Hello? Hmm? Why it is nobody is showing now? Hmm? Just tell him to again. Yeah. Number one. Is there anybody left? Hmm. Now see the disadvantages of the operator precedence parsing. Disadvantage, it cannot handle the unary minus. We have seen already the lexical analysis would handle the unary minus. This is applicable for small class of grammars, that is grammars deals with the different operators. Number three, difficult to decide which language is recognized by the grammar. These are the three disadvantages of the operator precedence parser. Now, what are the advantages? It's a simple one and powerful enough for expressions in programming language. That means mainly operator precedence parsing technique is used for expressions in programming languages. Programming languages. Find the programming languages. Uh, there is another relation, another algorithm, leading and trailing, for finding the operator precedence relation. But this is actually, but mostly it is done with the help of the precedence graph. That is why I have not discussed these things, but I will send these things. You just have it, go through these things. Now, Is this visible?
Yes, sir.
Now, we have seen two bottom-up parsing techniques. One is the shift-reduced parsing techniques. Another one is the operator precedence parsing technique. Basically, both are working in the nature of shift-reduce. That is, simple shift-reduce we have seen, and also we have seen the operator precedence parsing. Why operator precedence parsing? In order to overcome some disadvantages of the simple shift-reduce parsing. Now, next one is top-down parsing. We will just first we will discuss the basics of top-down parsing. Then again we will go back to the bottom-up parsing, remaining part of the bottom-up parsing. Top-down parsing is basically divided. Just it's a recursive descent parsing. Recursive descent parsing. What is recursive descent parsing? I am coming to these things. Recursive descent may be using the backtracking one and without the backtracking one. And popular one is the non-backtracking one. And there are two important parsers in the non-backtracking one. One is the predictive parser. Another one is the LR parser. Oh, sorry, LL parser. LL parser in the bottom-up category. That means recursive descent, top-down parser working in the recursive descent manner. They may be work in the backtracking recursive descent and non-backtracking recursive descent. And we are interested in the non-backtracking recursive descent version. This is predictive one and LL one. That means from the predictive parser, we just modify and we will update these things and we will get the concept of the LL parser. What is recursive descent parsing? Recursive descent is a top-down parsing technique that constructs the parse tree from the top and input is read from the left to right. Input is read from the left to right. It uses procedures for every terminals and non-terminal entry or entity. It uses procedures for every terminal and non-terminal entity. This parsing technique recursively parses the input to make a parse tree, which may or may not require backtracking. But the grammar associated with it, in case of no left factoring is there with it, if not left factored, I am coming to this term, not left factored, and because non-left factor cannot avoid the backtracking. A form of the recursive descent parsing that does not require any kind of backtracking is known as the predictive parsing. And predictive parsing technique is regarded recursive as it uses context-free grammar, which is generally recursive in nature. We just see what is backtracking. Just see, top-down parser starts from the root node start symbol and matches the input string against the production rules placed by if match, like these things. Let us see, this is a grammar. S produces RxD or RZD. Now X, capital X, this is the non-terminal, capital 1. Now capital X produces OA or EA and Z produces AI. Now, if for an input string read, the top-down parser will behave like these things. You just see, read, input string is read. Then from here we will start, either we will start from S, that is RxD or RZD. Okay, now we have start these things, suppose RxD. Now what is RxD? That is, you just see, now X produces either OA or EA. We have used, now X produces OA. That means what is that? You just see, in that case, ROAD. In that case, you will not reach to your, because your parsing sentence needs to be, or word is read. That means read, you have to find the parse tree for the read one. Input string is read. Then what you will do? You have to backtrack here and backtrack here. That means X will be replaced by next stage EA. and then you are getting READ. This is basically known as the backtracking. The backtracking means when you cannot proceed further and the final input string does not matches your original input string. That means final input string parsed or produced does not matches with your original input string. Then you have to backtrack to the previous level and just substitute that that previous level, that non-terminal, with the help of another set of production rules. And this way you will reach the end, and this is basically known as the backtracking. Backtracking. Okay. Is it okay? Are you understanding why backtracking is required? Okay. Now, here the same example you just see. String needs to be parsed, or you are going to find the derivation for string W equals to CAD. That means we are trying to find the derivation tree for CAD. We have start with S produces CAD, and A has been reduced by AB. In that case, you just see what are getting CABD. But this is actually not matches with the string to be parsed. This is the thing. That means we will backtrack here, and A will be, then A will produce small a. That means now you can see that we can backtrack and we can get our desired derivation tree for this CAD string. Now, this is the backtracking, that is why backtracking is required. Isa, I have just sent you the recursive descent functions for these two symbols, S and A. You just send it to everybody. Isa, are you there? Hello? Isa, are you there? Hello? 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 Am I audible properly?
Yes, sir.
Hello?
Yes, sir.
You just tell.
Yes, sir.
Yeah. Yeah. I've sent you in your WhatsApp the procedures for the recursive descent procedures for the two non-terminals, that is S and A, as per this grammar, and you just send it to everybody. Hello? Is it visible to everybody?
Yes, sir.
Just I have sent you the recursive descent functions for two non-terminals, that means S and A. Basically in the recursive descent that is done, that means for every non-terminal is associated with a function. Every non-terminal is associated with the functions. You just see. It's very easy. It will be clear to you. You just see the procedure, it will be very clear to you. Hello? You just see procedure
Yes.
S and procedure A. Procedure S, if the input symbol is C, input symbol is C, you just advance. And A, what is A? A is the non-terminal. That means A has a function itself. Every non-terminal has a function itself. Begin advance, and if A is a function, then if the input symbol is D, then begin advance and return true. That means function for procedure for S has been done successfully. This is the things. Now in case of A, you just see. Now A is, you just save the input pointer because you will start from S. Now you can reach to A, and that is why you need the input pointer. Where you just start. Is save equals to input pointer. If it is okay, that means input pointer current. You just see the current position of the input pointer. Now, if the input string or input symbol is small a, then you will advance. If the input symbol is B, then again just advance and return true. That means you have been successfully parsed A also. Otherwise, you just take the input pointer, you just see if backtracking is required. In that case, you just take the current value of input pointer to is save. That is why is save has been used. That variable is used to take the current value of the input pointer. Now, that is your failure to find AB, or you need backtracking and you have to go for only A. In that case, again, you can proceed in this way. And this is the procedure for A, and previous one we have seen procedure for S. Just see it and ask me whether is any difficulty for understanding the recursive descent parsing technique for the two non-terminals S and A. Are you understanding these things? What I have sent you in WhatsApp? Hello?
Sir, begin advance mean মানে এটা meaning কি?
Advance means pointer will move to the next position.
Okay.
Advance means pointer will move to the next position. And if there is no symbol needs to be parsed, that means you can declare that you have parsed successfully. That means it is true.
Okay.
I just like to know, am I properly audible? Because I have changed my laptop. There is a thing.
Yes, sir, you are properly
Yes, sir.
audible.
Yes.
Okay. Now you just see, this is the way actually recursive descent parser works. Recursive descent parser with backtracking works. Now we'll see the non-recursive nature of the non-recursive descent parser, that is non-backtracking nature of the recursive descent parser, and this is the predictive parser, which is the most important one in top-down parsing grammars. Predictive parser, that is in many cases, by carefully writing a grammar, eliminating the left recursion from it and left factoring the resulting grammar. I am coming to this term, left recursion and left factoring. The resulting grammar, we can obtain a grammar which can be parsed by the recursive descent parser that needs no backtracking, and that is known as the predictive parser. That grammar parser is known as the predictive parser. Now, before going to the details of the predictive parser, that is, predictive parser works after removing the left recursion and as well as removing the left factoring. What is left recursive grammar? You just see. A grammar is left recursive if it has a non-terminal A. It has a non-terminal A. Such there is a derivation A produces A alpha, where alpha is some string. That is, A produces A alpha And if you have any production rules of in this nature, that is A produces A alpha, then the grammar is known as the left recursive grammar. Left recursive grammar. Okay. And top-down parser can loop forever when facing a left recursive rules, and therefore such rules need to be eliminated. That is, you just see a left recursive rule is such that you just need to remember these things. A produces A alpha or beta if you have any grammar of these things. In that case, left recursive rules can be eliminated with this help of these rules, that is A produces A alpha or beta. Now A produces beta R and R produces alpha R or epsilon. Alpha or epsilon. This is the things. That is R be a new non-terminal and epsilon is an empty strings. And that is why you can remove the left recursion of the grammar. In most of the books, you will see A produces A alpha or beta, and this now instead of R, you can see this is a prime. That means A produces beta A prime, and A prime is alpha A prime or epsilon. For example, you just see the left recursion. What is left recursion and what are the rules for removing the left recursion? Then I am explaining it with an example. Just see next one. First one, we will see these things. You just see this is a grammar. E produces E plus T or T. T produces T star A for F, and A produces E or ID in parentheses or ID. First one, you just try to tell me whether grammar is a left recursive grammar, and if it is left recursive, how you can judge that this is a left recursive one. Can you tell me whether this grammar is a left recursive grammar or not? Hello? Hello?
Yes, sir.
This grammar is a left recursive grammar or not?
Left recursive.
You just see why left recursive? Why we are saying what is a left recursive? That is A produces A alpha or beta.
Yes, sir.
This grammar contains these things. A produces A alpha or beta. You just see this is A. A produces again, that is E produces E. Non-terminal produces the same non-terminal. You can consider this plus T as alpha, plus T as alpha, and E is A. That is A produces A alpha or beta is your T also. Now,
Yes, sir.
what is that? How to remove the left recursion? That is A produces beta R, or I have told you, you can consider as A prime. A produces beta A prime, and A prime produces alpha A prime or epsilon. You just see that is E produces T E prime. E produces T E prime. A produces alpha A prime, and A prime, that is E prime produces alpha A prime or epsilon. As I've told you, alpha A prime. Alpha, what is alpha? I have told you A alpha plus T is alpha. Alpha A prime, that is E prime or epsilon. Like this for T produces T star A for F. Just if you matches with the A produces A alpha or beta, then A is T and alpha is star F and beta is F. That is A produces A alpha or beta. Now, what is that? If A prime produces, that is A produces alpha A prime, A produces alpha A prime, that is T produces F T prime, and T prime produces alpha A prime or epsilon. That is the things. A produces beta A prime, just or beta is F, A produces beta A prime and A prime produces alpha A prime or epsilon. Just a minute. কথা হচ্ছে? আচ্ছা ঠিক আছে। আমি তো দেখিনি মেসেজটা কিনা কখন পাঠিয়েছে। না খেয়াল করতাম আমি যেখানে Is it okay? Are you understanding these things? That means eliminating the third rule is don't have a left recursion. That is, it will remain as it is. But previous to, are you understanding? Just see this rule again. A produces A alpha or beta. This can be avoided using A produces beta A prime and A prime produces alpha A prime or epsilon. And based on these things, we are finding the, that means this grammar is a left recursive grammar and we are trying to overcome the left recursion, the eliminating the left recursion one. You just tell me whether it is okay, you are understanding or not.
It is okay, sir.
Everybody, is it clear?
Yes, sir.
Yes, sir.
You just see this is a single rule and this is a generalized one. That means in this way, if the group A rules is like these things, A produces A alpha 1, A alpha 2, A alpha m like these things, or beta 1, beta 2, beta n like these things. Now replace the original A rules with this concept, that is A produces beta A prime or beta 1 A prime or beta 2 A prime or beta n A prime like these things, and A prime is alpha A prime or alpha 2 A prime or alpha m A prime, and finally epsilon will come. In that case, you just see this is the, will not eliminate the indirect left recursion of this kind. This is just direct left recursion. That means here you just see A produces BAA. It is not the left recursion as per the definition, but A produces A. This is also indirect form of left recursion, and this rule does not eliminate this kind of left recursion. Mainly we are dealing with the direct left recursion, and which can be overcome using this or this generalized one, and we have seen these examples. This is the things. This is basically removal of the left recursion. Now you just see this is the recursive descent grammar for this grammar. That means after eliminating the left recursion, we are getting these things, and this is the recursive descent backtracking nature of the grammar, like these examples. Already we have sent the S and A, and this is for E, E prime, T, T prime, and A. Same recursive descent procedures. Simple way, just E produces T prime, that is you are calling, because you are every functions you are calling, that means T and E prime. But when some non-terminal symbols are there, in that case, you just check if input symbol is plus, then advance, then you are calling T and E prime. And this is for F T prime, F T prime, and T prime basically input symbol is star, then advance F and T prime like this way. And A produces E or ID, just the input symbol is ID, then advance, else input symbol is opening parenthesis, then advance and call E. Now input symbol is closing parenthesis, then advance, and return true, else return false, or return error, like this. Is it okay? हेलो, समझ में आ रहा है? বোঝা যাচ্ছে? Are you understanding these things? Now left factoring. What is left factoring? Not only just left recursion is not only, that is removal of the left recursion is not only the solutions. That means another is whether the parser can always choose the correct right hand side on the basis of the next token of input using only the first. Okay, just see what is left factoring. You just see. I'm showing you the examples, then you just see. If the grammar is in this way, A produces alpha beta 1 or alpha beta 2. You just see, forget about the remaining part. That means you just see all alternatives begin with alpha. All alternatives begin with alpha. In that case, it will very difficult for the compiler or the parser to recognize. That means what is the next symbols there, or next, what is the next symbols in the production rules, because it has been started with alpha, but it has beta 1 and it is beta 2. In that case, what you will do? In that case, you just see A produces alpha A prime and IA prime produces beta 1 or beta 2 or beta n, like these things. And this is basically, if some symbol is there, you just put these symbols here, gamma or like these things. That means in order to overcome these things, that means for every non-terminal, find the longest prefix alpha common to two or more of its alternatives. Alpha is common here. And that is why it is very difficult to recognize what is the next symbols needs to be passed, because based on the production rules, you won't be able to see this. That is why this is basically known as the left factoring, and we can remove this left factoring technique with the help of these things. A produces alpha A prime or gamma, and A prime is beta 1 or beta 2 or beta 3, like these things. This is basically left factoring gamma. And you just see the example. S produces IETS. If expression then statement, like these things. If expression then statement, else statement, like these things. Here also you just see this is the example of the left factoring. Because you cannot understand based on both of them started with I, and now based on this I, or here you can see after S, what is there? S followed by nothing, or S followed by ES. S followed by nothing, or S followed by ES, like these things. Then it will be very difficult to recognize these things or understand what the next symbol to be passed. And in that case, what we have done? S produces E, I, E, T, S, S prime, and S prime produces either epsilon, here epsilon, or ES, like this one. This is the example of removal the left factoring for this particular grammar. Is it okay?
Yes, sir.
Yes, sir.
Do you have the class now?
Yes,
Do you
sir.
have any class? From 10. When you have the class?
10:50.
10:50. Okay, actually predictive parser, I cannot finish it today itself because things. Okay, tomorrow I will take the class from 9 a.m. and up to which will be covered tomorrow will be in your mid-sem syllabus, and I will take the mid-semester on coming Monday.
Okay, sir.
Got it?
Yes, sir.
Yes, sir.
Okay. Okay. See you in the next day. Tomorrow at 9 a.m.
Okay, sir.
Okay, sir.